Hello everyone, welcome to my YouTube channel, the Mathematics Foundation classes. Today we are going to learn the functions. In the previous class we learned relations. So let us see what is a function. What is a function? A function is a special type of a relation, but all the relations are not functions. So a function is a special relation, and it is very important in mathematics. Let's see the definition. A function is a relation from a non-empty set A to a non-empty set B such that each element of A has one and only one image in B. A function is a relation from a non-empty set A to a non-empty set B such that each element of A has one and only one image in B. For example, this is the set, non-empty set, so it has A, B and C. B is another set, we have elements P, Q, R, S. And this relation from A to B is a function, so we write it's a function. Each element of A, here we know that A has three elements, each element A has one and only one image in B, one and only one element in B, that each element of A. So there are two conditions here. One is each element of A has image. Number two, one and only one image. Each element of A has one and only one image in B. So two conditions here I think that should satisfy. Each element of A has image. Okay, and no element of A has more than one image. So two conditions here, each element of A has image, so A has image, B has image, suppose A has image, B has image, C has image. The P is the image of B, Q is the image of A, and R is the image of C. So all the elements in A has image in B, and no element is having more than one image. Therefore we call F is a function. So the definition is very important here. A function is a relation such that every element of A has one and only one image in B. Every element of A. So two conditions here, each element of A has image and no element of A has more than one image. I will show with some pictures the functions and non-functions. Here on example, A is a set, A, B, C. Here B is, this is from A to B, this is a relation from A to B. And P, Q, R, S, A. has image P, B has image Q, C has image R, therefore R is a function. It is a function. This is example 1. Number 2. A and B here. A, B, C, P, Q, R. A has image P and again A has image Q, B has image R and C has image S. Now look at the second example. The second example is all the elements, okay, first condition is correct. Each element of A has image, B has image, C has image. But no element of A has more than one image. The element of A has two images. Therefore, it is not a function. It is not a function. Because the element A has two images in B. Another example. Example 3. Third example. A, B, a relation from A to B. A has element A, B, C, D. I have taken one more element here. B has P, Q, R, S. Okay. A has element and B has, then C has, okay, but the element D does not have image, so D is not used here. Therefore, the definition, as per the definition, all the elements in A should have image is not satisfied here because the element D is not used here, therefore it is not a function. It is not a function because the element D has no image. Fourth example. Fourth example is A, B, A, B, C, P, Q, R. A has image P, B has image Q, C has image R. Therefore, we know that all the elements have in A has image. All the elements A has image B, B has image Q, C has image R. Therefore, all elements of set A have image in B, and no element is having more than one image. Therefore, it is a function. It is a function. It is a function. Now here you should know what is actually domain and range here. Domain. Domain is the set of elements of the first set A. So that is A, B, C here. The elements from the first set is called domain. And the elements in the second set is called codomain. Codomain is the elements in the second set, that is PQR or PQRS. PQR, second set. So elements in the first set is called domain and elements in the second set is called codomain. But then again you know that the range, what is range? There can be confusion between codomain and the range here. Look at here. Here domain ABC, codomain is PQRS. Here also domain ABC, codomain is PQRS. And range here, the range here is only PQR because PQR are only the images. S is not the image of any element of A. Therefore, S is not used here. So the image of A is P, image of B is Q, image of C is equal to R. Therefore, the range is PQR. If you want to know what is the range, then PQR are the elements in the range. But the elements in the codomain will be PQRS. The codomain will have all the elements, but the range is only the elements which are images of the non-empty set A. So the range here is, in this case, is P, Q and R only. This is about domain, codomain and range. Next we are going to learn the types of functions. First one is one function. Or it is also called bijective function. One function or bijective function. One function is a function f from x to y is said to be a one function if distinct element of x have distinct elements in B, elements in Y. Distinct elements of x has distinct elements in Y, which means for every x1, x2 belongs to x, and fx1 equal to fx2 implies that x1 equal to x2. Simply, if you talk, the relation from the function from A to B. The function from A to B the function from A to B, sorry, the function from x to y, the function from x to y is said to be an one function if distinct element of x have distinct image, which means each element of the first set, domain set, has its own image. A has its own image, B has its own image, C has its own image. Distinct element of x have distinct images, individual, or each one is having its own image. A is having its own image, B is having its own image, C is having its own image. Those functions are called one functions. And another definition for x1, x2 belongs to x. fx1 equal to, this is also a definition another way. For every x1, x2, if you take any two elements in the x, fx1 is the image here. Here if you take the element is x, then the image here is called fx, function of x. So fx is the image of x. So if x1, x2 are the two elements in x, then fx1 and fx2 are the two images are equal, then the elements must be same. The elements must be same. Then only we can say fx1 equal to x2, which means both are all the elements have individual its own images. Okay, this is the one function. Now, what is the what type of functions are not one function? That let's see that. I will show an example here. This is x, and the function from x to y. F is from function from x to y. Now a, b, c, and here p, q, r. So, okay, a is equal to p, and q, and here Okay, so the image of P is equal, the image of A is equal to P, the image of B is equal to Q, and the image of C is equal to also Q is equal to. So sometimes we may confuse here because you know that the images B and C, both elements have the same image. Is it possible? Because as per the definition, you know that definitions clearly say that all the elements in A should have image. Yes, all the elements of A has image, B has image, C has image. Condition first is okay. Condition 2 say that no element is having more than one image. No element is having more than one image. Okay, therefore Q is the image of B and C, doesn't matter. So here B and C, two elements share the same image. Okay, which means B is not having its own image, C is not having its own image. They are sharing it there. So this kind of functions are not 1, 1. It is not 1, 1. And such functions are called many one functions. Many one function, not 1, 1. If the functions are not 1, 1, we call it as many one function. So we write here, if the function f is not 1, 1, then f is many one. The element in A, 1 or 2 or 3, or some elements of the domain set has more than one image. Okay, not 1, 1, so it is called many one functions. Next is onto function. Number 2, onto function, or it is called surjective function. Onto function or surjective function. Okay. A function f from x to y is said to be onto function, said to be an onto function if every element of y is the image of some elements of x. Every element of y is the image of some elements of x, or that is, for every y belongs to y, there is an element in x such that f of x equal to y. It's very clear. Onto function, it is also called surjective function. A function f from x to y is said to be onto if every element of y is the image of some elements of x. For every element of y, we know that y is the codomain. For every element of y is the image of some elements of x. Look here, this is the set x domain set, and this is the set phi is the codomain set. It's a function from 2b. Okay, now a, b, c are the elements of the domain set, and p, q, r are the elements of y. Now here the definition says that every element of y, that is p, is the image of some elements of x, so which means p must be the image of some elements here, either A or B or C. Okay, let be A. And Q, again, it must be the image of, say, C. And R, the image of B. Earlier we found that sometimes S which is left not used in the set. So that is not possible here. Every element of Y is the image of some elements of the domain set. Every element of Y, which means simply if I say that all the elements in Y must be used there. No element left here which does not have an image in it. So every element of Y is the image of some elements of X. That is, for every element Y belongs to Y. For every Y represents, small y represents the elements here, and small x represents the element in the domain there. For every Y belongs to the set Y, there is an element in X. For every Y here, for every element in the codomain, there is an image in the domain. No element is left without a partner in the domain set. So such that fx equal to y. Fx means the elements all are called fx only. For example, in the first set we take x and the image in the codomain is called fx. So x represents the elements in the domain, and fx, function of x, which is also we call y, is the element in B. Okay, this is that. So it is called onto function, or it is called surjective function. Now let us see which one is not surjective, which one is not onto. We can see that it is onto. Here it is onto or surjective. Now A here and B is here. The relation, the x here and y is a function from x to y. Now A, B, C, P, Q, R and S. So here A is, now P is the image of A, Q is the image of B, R is the image of C. Now here C. S is not the image, one extra there, S, which does not have any partner in the domain set X. So this is not on, therefore it is not onto. The reason is that the element S is not the image of. The reason is that the element in Y, that is, the element S in Y does not have a pre-image in X. Pre-image in X. So this is called into function. If it is if it is not onto, we call it into function. So this is called into function. Okay. So a function f from x to y is said to be onto or surjective function if every element of y is the image of some elements of x. Okay, it is called onto function. And if the function is not onto, it is into function. So today we learned that the function, what is a function and different types of functions there. Then domain, codomain and range. And if first a function, the types of function, first one was that one function. If it is not one, it is many one function. What is the one function? Every element in the domain set has its own image. Every element in the domain set has its own image. And onto function is that all the elements in the codomain, all the elements have pre-image in X. This is about, okay. Then let's see some examples here. Before we started the examples, if a function is bijective, that is 1, 1 and onto, it is 1, 1 and onto. If a function is function is 1, 1, 1, 1 we called injective, and onto if a function f is called, if a function f is 1, 1 and on 2, then f is called bijective. Bijective function. Both 1, 1 and on 2. 1, 1 is injective, on 2 is surjective. If a function is 1, 1, that is injective, and on 2 surjective, then we call the function f is bijective. We can see some examples of injectivity and surjectivity. Here we have one example here given, the function from n to n, natural numbers to natural numbers, given by fx equal to x square. I told you already fx is in the first set the domain elements, x represents domain elements and the codomain represents fx, x to fx. So fx is the image of x. Now here we can see the fx, the image is x square, where x is the element from the domain set. So let's see that it's a function from natural number to natural numbers. Natural numbers, you know the natural numbers are having the elements 1, 2, 3, 4, etc. Infinite numbers are here. Okay, and here again 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. Okay, infinite numbers. Then the function f from n to n such that the definition is fx, the image is equal to square of x, square of the image. So let's see that the square of x, if x is equal to 1, so x represents the elements in the domain, fx is here. If x is equal to 1, so it is f of 1 equal to 1 square, which is 1. So it is 1. Okay. Then if x is equal to 2, f of 2, which is x equal to 2, then 2 square, which is 4. So it comes 2 to 4. And f of 3, x equal to 3, f of 3 is equal to 3 square equal to 9. So here in this case x is equal to 1, in this case x is equal to 2, okay, and here x is equal to 3. So here 3 to 9, and if 4 definitely it will be 16, 5 will be 25. So what kind of, let's see now. In the set, all the elements definitely will have images because 4 square, 5 square. So from natural numbers we can find it out. But we can see that, do you think this is a, it is onto function? Definitely it is one function because each element in the domain has its own image. Its own image. 1 is having its image 1, 2 is having its image 4, 4 cannot be the image of some other elements of x, and 9 is the image of only 3. 9 is not the image of other element of n in the domain set. And 4 the image will be 16, and 5 the image will be 25, but there are some elements which are not images of any element. So this is, it is, f is 1, 1. It is 1, 1 function. So it is 1, 1 function means it is injective. It is injective. But since there are some elements here which are not images of some elements in X, there are some elements here in the codomain which are not the images of some elements in the domain. Therefore, it is not onto. For example, here 2 is not used. 2 does not have a partner, and 3 it's not the image of here. Therefore, f is not onto. Therefore, it is not surjective. Not surjective. Okay. Let's see the second example here. Here in this case, the function is defined from z to x. Z is integers. Integers to integers. Integers. Okay, first set is f. Z to z. Integers to integers. So here we know that negative integers, negative 1, 0, positive 1, positive 2, positive 3, integers negative 2, negative 1, 0, 1, 2, 3 and etc. Okay, so infinite number of elements here. Now let us see some example here. First of all, let us see the one injectivity. Minus 2. If you take minus 1, what about minus 1? So the definition is fx is equal to x square. If you take x is equal to minus 1, x is equal to minus 1, f of minus 1, which is minus 1 the whole square equal to 1. So minus 1 be 1. F of 0 definitely will be 0. Then f of minus 2 will be the same way 4. It will come to 4. F of minus 2 will be 4. F of minus 2 will be minus 2 square equal to 4 because fx is x square. When you put x equal to minus 2 square. Then let us see f of 1. F of 1 is equal to 1 square, which is also 1. So f of 1 is also 1. Okay. So, and f of 2. F of 2 is equal to 2 square, which is also equal to 4. F of 2. Now we know that, okay, definitely all the elements in Z, have images in the codomain, doesn't matter, therefore it is a function only. But we can see that distinct elements do not have distinct images. Minus 1 has the image of 4, which is the image of 1 also. The two elements have the same image here. Therefore, it is not 1, 1. It is not 1, 1. Because it's many 1, not 1, 1. So, not injective. Not injective. It is many 1. Same way 2. 2, the 4 is the image of negative 2 and positive 2. Negative 2 square also positive 4, positive 2 square also positive 4, same way. Therefore, it is not injective. And what about on 2? That is the surjectivity. Let us check the surjectivity. There are some elements here. Which are not the images of x here. For example, 1 square is 1, then 2 square is 4. What about 3? Negative 3 or positive 3. Those elements do not have a pre-image here. So some elements, it is not on 2. It is not on 2 or not surjective. Because reason is that some elements like negative 3, positive 3, these elements, negative 7, positive 7, these elements are extra here which are not images of some elements of the domain set. So which is not on 2, right? On 2 I think all the elements must be, all the elements of y are the images of x, or in the domain set. Therefore it is not surjective. Let's see, just to review what we learned today. Today's lesson started with the definition of function. So what is a function? And function is a relation from a non-empty set A to a non-empty set B, such that all elements of the first set are used in the function and the relation, and no element in set A has more than one image in B. Okay, these are the definition. Then we learned that domain is the first set and codomain is the second set. So if the relation is from A to B, set A is called domain and set B is called codomain, but whereas the elements used in codomain is called a range. Then we learned the types of functions here. That is one function that is called bijective function. Bijective function is from the non-empty set to non-empty set to B. All the elements have its own images, and if it is not 1, 1, it is called many one function. Then second type is called onto function, that is surjective. Surjective function is a function such that all the elements of the set Y, that the codomain, are images of some elements of X. So if it is not onto is also called surjective, and if it is not surjective, it is into function. And if a function is both onto and one, we call it is a bijective function. These are the portions we studied today. Thank you. So thank you everyone for listening me. If you like my video, please like, share and subscribe.